Bryna the science gal. Bryna.
Hi, I'm Bryna the science girl, and today's topic is going to be intermolecular forces. Intermolecular forces are forces that exist between molecules. Please remember, however, that these forces are much weaker than the forces that exist between the atoms of a molecule, known as intramolecular forces. First up, London dispersion forces, and we have a special guest for you on location in London. Where's London?
Hello, I'm Mary Poppins. What's all this now? London dispersion forces aren't just in London, but are present in all molecules. These forces occur because of an instantaneous dipole moment caused by an uneven distribution of electrons in atoms. Because these forces are weak, they are only in effect when molecules are very close together, and the effect increases as the molar mass of the molecules increases. The effect also increases as the shape of the molecule becomes longer and more chain-like. London dispersion forces, along with dipole-dipole forces, are van der Waals forces.
Hello, Mary Poppins. I just came out of chimney. The main difference between dipole-dipole forces and London dispersion is that dipole-dipole forces occur between polar covalent molecules. Electrostatic attractions occur between the partially positive end of a molecule and a partially negative end of another. Also, dipole-dipole forces increases with increasing polarity.
Thanks, friend. Substances only affected by van der Waals forces tend to be gases at room temperature and have low melting and boiling points.
Thanks, girls. Now, the next step in our miraculous journey is hydrogen bonds. This is an attraction between polar covalent molecules. This occurs when a hydrogen atom is attracted to an electronegative fluorine, oxygen, or nitrogen atom. And now here's a friend to help you remember. It's the funs!
Hey! Look, examples. Hey!
Merci, Fons. Because hydrogen bonds are stronger than van der Waals forces, molecules with hydrogen bonding have higher melting and boiling points. Hydrogen bonding can also explain why water is less dense in its solid form than it is in its liquid form. Oh, hello. I didn't see you there. But did you know, an ion dipole force is even stronger than a dipole-dipole force? Here to tell you more is Jennifer Poppins, Mary Poppins' American cousin. Through the air, then we go!
Thanks, Bryna. Ion dipole forces exist between an ion and a polar molecule. Cations, or positively charged ions, are attracted to the negative end of a dipole, and anions, negatively charged ions, are attracted to the positive end of a dipole. The forces increase as the ionic charge or magnitude of the dipole moment increases. This force allows for the dissociation of ionic substances in polar liquids.
And now the strongest of them all, ionic bonds. Take it away, Emily.
Ionic bonds exist between oppositely charged ions. The ions are formed from atoms by transfer of one or more electrons. As the charges on the ions increases, ionic bond strength increases as stated by Coulomb's law. The forces of attraction is equal to the product of their charges divided by the square of the distance between them. Ion charge is directly proportional to bond strength and inversely proportional to ion size. Ionic bond has the strongest intermolecular forces, and thus it has the high melting and boiling point temperatures.
Bryna the science gal.